All right, well, we're entering into today one of my favorite sections, our favorite chapters actually, is all the statistical stuff that we're going to do in chapter 10 here. So some pretty good stuff. I think if you enjoy numbers and probability and those kinds of things, you're going to enjoy this. One of the key terms that you're going to need to know for this is permutations. And permutations is an ordering of n objects. So it's putting things in order. And in this case, what you need to remember is order matters. It is important what order you put things in. Anytime you have a real-world problem where order is important, you're going to want to be using a permutation. And anytime that you have a real-world problem where order doesn't matter, you're going to use a combination, which we're going to learn about in the next lesson. So in factorials is something like 8, like we say it like that, or we say 4, and we have an exclamation point right here. And so what we're doing is we're not exclaiming 8 or exclaiming 4. 8 actually means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or 4 actually means 4 times 3 times 2 times 1. So that little exclamation point there means factorial, not actually screaming into the microphone. When we're looking at the fundamental counting principle, this one, if one event can occur in m ways and another event can occur in n ways, then the number of ways that these events can occur would be m times n. All right, three or more events. Well, you just keep multiplying them out. M times N times P. So I went and found out on the internet. I got us a little picture of a pizza here for our next problem. You are buying a pizza. There's our pizza. And you have a choice of 3 different crusts, 4 different cheeses, and 5 meat toppings, and 8 vegetable toppings. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose? Well, I can choose 3 different crusts. I can choose 4 different cheeses. I can choose 5 different meats. And I can choose 8 different vegetables. That's how many different ways I can do the whole thing. So I just multiply those out, and I get 480. 480. There you go. All right, let's... On this page here, we're talking about, well, first you have a checkpoint. Can you guys go ahead and do that checkpoint for me? Take a moment. All right. If the pizza crust was not a choice, how many different slices could be made, or how many different choices can be made? All right, so if we cut out that, we would have 4, 5, and 8 were my choices left. So 4 times 5 was 20. 20 times 8 was 160. So if we cut out the crust as a choice. Sorry for that pause that I had in there. I tried to go back and wasn't working real well. Let's change colors here. Telephone numbers. So I went and got my little telephone numbers, and it says a town has a telephone number. Has telephone numbers that all begin with 329, and then they're followed by 4 digits. You know, kind of like we have around our area, 554s and 698s and those. So this one town probably doesn't have a ton of people in it. They all start with 329. How many different phone numbers are possible if numbers can be repeated and if numbers cannot be repeated? Well, there are 10 different digits to choose from, 0 to 9, right? And the phone numbers, if I have 4 different choices, if I can repeat them, like I could have a number 3297777. Okay, so I can repeat the numbers. Would be 10 times 10 times 10 times 10. Okay, that would be a 1 and 4 zeros. That means once you have 10,000 phones out there, you better start coming up with a new first 3 digits. If you could not repeat the digits, if you thought, you know what, you can't have a number like 7777, you could have 7894 or whatever. You'd still have 10 choices for your first number, but once you selected your first number, you only have 9 numbers left to choose from, and then 8, and then 7. So if I multiplied all those numbers together, I get 5,040. Really almost half of the same number of people that you could have there. So coming up with phone numbers, that's certainly something you got to think about when you're coming up with those numbers, I'm sure. Just like in Michigan, we just added a new, they just added a new area code. The first 3 digits were in the 616, but they just added to the other side of the state 989 and those to the 517s, and so that was so they could have more numbers. Hope that makes sense. All right, let's get that phone out of here. Playoffs. 8 teams are competing in the playoffs. In how many different ways can the baseball teams finish the competition? So how many different teams could finish first? Well, 8 teams could be first. But once you have your first place team, how many people can finish second? 7 and 6 and 5 and 4 and 3 and 2 and 1. Or 8. And if you look under your math key on your calculator, that would lead you right to your factorial button. 8 factorial happens to be 40,320. This is not to take into account that one team is not very good and the other teams may be very good. Any of the 8 teams could finish first. The second part of the question is how many different ways can 3 of the baseball teams finish first and second? 7 could finish second and 6 could finish third. 8 times 7 times 6 gets me 336. All right. Next, we're going to take a look at permutations and exactly what permutations are and what they mean and how they're used. So here's the formula that we use for permutations. Now, if you look under your math key and probability, you'll see an NPR key. And when you do it in your calculator, you want to do like, 8 NPR 6 or whatever. If you put that in your calculator like that, that's how it works. So feel free to do that. But we do want to show you real quick what your calculator is doing in that situation. So I did 6 permutations 4, or you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. And how many orders can you complete the 4 assignments? This is, I could do my English first, or I could do my math first, or I could do my science first. The order is important here. They've made order important. Not how many different ways can you do 4 of the 6, but how many orders can you do it. So they made sure they put that in there. Well, if I follow this up here, I have the 6 factorial over 6 minus 4 factorial, or 6 over 2, and 6 is 720, and 2 is just 2, because it's 2 times 1, and that leaves me with 360. You can complete the 4 assignments in 360 different ways. All right? You go ahead and take a look at number 2 there. All right, we're going to do actually 2, 3, and 4. I hope you're doing all of those. How many different 7-digit phone numbers are possible if all the digits can be repeated? Well, 10, 10, 10, 10, 10, 10, 10. Or a 1 and 1, 2, 3, 4, 5, 6, 7 zeros. 10 million different phone numbers. Now, we know that you can't have numbers like 911 and all that stuff. Your phone number can't spell out a bad word. So there's a lot of things that they'll make sure that you can't have on your phone numbers. But 10 million would be the answer. In example 3, how many different ways can teams finish if there were 6 teams competing in the playoffs? Well, that ends up being 6 factorial, which is 720. And you were left a list of 9 chores to complete. And how many different ways can you complete 5 of them? How many different orders, remember orders, can you complete 5 of them? 9P5. 15,120. Put that in your calculator. And permutations with repetition. A number of distinguishable permutations of n objects where one object is repeated s sub 1 times, another object is repeated s sub 2 times, and so on and so forth. We're going to do, in this one, we're going to do different wording. I just brought a little picture of California over here. I thought it would be nice to have in our video. Find the number of distinguishable permutations of letters in something like even. All right. If I'm doing the word even, there's 4 letters in even, in which E, the letter E, is repeated 2 times. So the number of distinguishable permutations is going to be 4, because that's how many letters it has, over 2 factorial, the number of times it's repeated. Now remember, 4 factorial means 4 times 3 times 2 times 1, and 2 factorial means 2 times 1. So the answer, if I take a 2 times 1 off top and bottom, the answer ends up being 12. That means I could write even, or I could write EV any, switch those last ones, or I could write NVE, or I could write ENEV, or I could write EENV, or EEVN, and you kind of get the point. I can just keep repeating. These are all the ones that could start with the letter E, and then I could do all the ones that could start with letter N, and all the ones that start with letter V, and I end up getting 12 distinguishable permutations, because I could do N, V, E, but that's the only one I could do. I couldn't do N, V, E again. That's why the 2 kind of eliminates some of them. I could do N, E, V, E, and I could do N, E, E, V. All right? So that's, so far, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can start with V. V, N, E, E. Do it up here. V, E, N, E. And V, E, E, N. So there's the 12 different things I could come up with this letter, 4-letter combination. And you see why, with the E's in there, how that changes some things around a little bit. Say the word California. In the word California, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters, right, in California. So on the top, I'm going to have 10 factorial, pretty big. But the A, all right, Hollywood, get you out of there. The A and the I are repeated. And each of them are repeated 2 times. And so on the top, I'm going to have 10 factorial. But on the bottom, I'm going to have 2 factorial and 2 factorial. All right? So if I have something like that, 2 factorial times 2 factorial is actually just the number 4. So I really have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Don't really need the times 1. All divided by 4. Well, the 4's now eliminate each other. I have the rest of the stuff. And if I put all of that together, I get 907,200. Not too bad. All right, you guys do these next 2 words. Just pause, see if you can come up with the answer real quick. Do those next 2 words. All right, welcome back. Hopefully you counted that there are 1, 2, 3, 4, 5, 6, 7, 8 letters on top, 8 factorial. And the letter O is repeated 3 times, so I have a 3 factorial. And the letter R is repeated 2 times, and that's a 2 factorial. So if I do all that work, I'm going to get 3,360. And yesterday, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 factorial on top yesterday. 3, 6, 9, yep. And then repeated is the letter E 2 times. The letter Y 2 times. That looks to be it. So there's going to be many more of those yesterdays than tomorrows. I hope I'm not so old that all my yesterdays outnumber my tomorrows. All right. You guys have a wonderful day. Thank you very much, and I will see you tomorrow.